Okay, so we have drafted the EC cover, and in doing that we created surfaces that created the core and the cavity, and we published the geometry to 2 steel plates and removed those so that we created an actual steel tool. So we created the core and the cavity parts of the steel tool. What I wanted to show you guys in this is a draft check. Anytime you get a part that is not designed as a plastic part, the first thing you want to do is look at the draft check to see if anything is already drafted by natural angles. So if I type in DC, it brings up a draft check. If you don't have that map key, you're going to go to Tools, Analysis, Geometry, Draft. What draft is the angle of the surfaces that allows a part to be pulled from the tool. When you're in Pro Engineer or Creo, if you right click, it's going to toggle through the surfaces. So if I'm over here in a surface and I'm right clicking, it's going to toggle through to the next surface, the next surface, next surface, until it gets to something that we call solid geometry. So allow that to come open. The reason that it was picking the outside and the inside is because I had 2 surfaces over here. If I right click over here, I can change a selection filter to say that I want the solid geometry only and grab it. So selection filters are very nice whenever you're talking about surfaces. Okay? So especially quilts. Quilts are multiple surfaces. A surface is an individual surface. A facet is a face. Solid geometry is the entire part or a component of an assembly. Alright, so we're going to go to solid geometry. The direction that we're going to pull this can be a plane. It could be a datum plane, or it could be a plane on the part. And what you want to look at here is notice all this zebra striping. There's a reason for that. There's surfaces over my part. So the surfaces, they allow this zebra striping. So I'm going to get out of this. It's like I have something overlapping. So if I suppressed all these features at the end, then I'm not going to have that. So if I go to Analysis, Geometry, Draft, I'm going to start right clicking until I get to solid geometry or select that in my selection filter. The direction is this direction. That's where the 2 tools shut off the 2 plates of steel. And it doesn't matter if I select a plane above or below that point. I just need a plane that's parallel to that direction, or normal or perpendicular to it's parallel to the direction of pull. So if the steel slides apart in the direction of this yellow arrow, that's what I want to see. I want to see it slide apart and drop this part out. We're going to change this to the largest, the draft degree on each side. Notice over here we have 0. We have negative draft, we have positive draft, or plus 3 degrees, minus 3 degrees. That's just in each direction. So different colors for different directions. We're going to go back to the largest draft that we can get on our part. So if we said that the walls are 1 degree, the ribs are 1/4 degree because they're taller, and the ears and the holes for mounting are 1/2 degree. So I'm going to do that. You can bump up this quality if you want to, and then look at it. So I'm going to regenerate this, and it starts again. So I can right click until I get to solid geometry. The direction is here, 1 degree. And as you bump up quality, of course, it's going to be slower. So if I spin this around, everything that's going to be on the cavity of this tool is going to be in pink or coral. So you can see that it goes from 1 degree, that's all the pink, and then it gets less, but it doesn't get to 0. 0 would be white. Now if I turn this around again, everything inside here, it looks like I've got, well, that was just a graphical error, but I've got everything inside here should be some shade of the other color. If I wanted to check for every instance of the angle, I can go to 1/2 degree and make sure that the things I drafted at 1/2 degree are that color, and then I can go down to 1/4 degree which should be the ribs only. Now everything should be purple here now because the ribs are, let's do this, the ribs are 1/4 degree and this is larger, so anything at 1/4 degree or larger is going to show up in purple. So it's going to show anything that's at least 1/4 degree and up. So what we're going to do now is we're going to run a draft check on this as is. So how do you think this part could be pulled? How could it be pulled out of the tool?
Side action.
You're going to have side action this way, right? To pull through this hole. And you're going to have side action this way because this rib, you can't blow through this rib.
Also, would it be best to split along that?
Yes, very good. So to split along this plane right here in the middle, and if I turn the planes on, that would be this right plane. That would be your splitting plane for a split draft. Split draft means that this is your hinge. It's also the direction of pull. A hinge can be a sketched curve, as we learned last time, or it can be a plane. So let's look and see what else cannot be pulled from the right direction. Can we pull anything perpendicular to that? Cannot be pulled. Anything parallel to that plane cannot be pulled in that direction. So the axis of this hole and the axes of these pins cannot be pulled that way. So if we kind of looked at this, and if I said, let's look at this as front and this as top, looked at it from the side. And so if I had a piece of steel here pulling up this way and a piece of steel here pulling down this way, how do I get this hole in? I'm going to have to pull this one this way, and these pins would be pulled this way. This would be a 4-part tool. Now, since these holes are right on the edges or the extents of the parts, those are called slides. They just simply slide away from the tool and get out of the way before these two pieces are lifted up, because these are going to be pins. If I turn this a wireframe, these are going to be pins sticking in here, right? And they're going to shut off right here. So what does that tell me about this right here? This needs to be drafted down. This needs to be drafted down, right? So that's what you're going to look at. So let's look at the draft check as is. So if I do a draft check, and I say solid geometry, and I select a part, and the direction of pull being this, split plane. Now that's 0.25 draft. We're going to use more draft than this, but we're just going to look and see at what point do we not have any draft. No draft on this cylinder, this cylinder. We've got anything that's rounded is going to have draft on it. So these flat planes don't have to have anything if it's parallel to the parting line of the two things. But anytime you have a round, it's going to be okay until it flattens out. So the rounds are good. They're going to add the draft in there. We want to put the draft in before the rounds, though. So guess what's going to fail? The rounds are going to fail. That's exactly right. So now if we change our drafting, so let's say 1 degree. Let's say we're going to make this whole thing at 1 degree. What was our rule of thumb? It was 1 degree of draft for each inch. So let's find out how wide was this thing. If I go to analysis measure, from one side to the other, this side to this side, it's 84 millimeters. So if we change that to inches, 25 millimeters in 1 inch, it's about 3 inches, right? Okay, so we may have to have up to 3 inches of draft. So it's only 1.5 inches this way though, right? And 1.5 inches this way. So we can have 1.5 degrees each way. Does that make sense to you guys? We could do a split draft with 1.5 degrees each way about this plane. Now anything that gets too small, such as this, you're going to measure across this. So let's measure this again. From this edge to this edge. That distance is 34 millimeters. That's just over 1 inch. 25.4 millimeters in an inch. If I actually just change the units of this part to inches, we would find out what the draft needs to be. Alright, so what I'm going to do real quick is I'm going to take a screenshot of this. And I'm going to do this so that I can put the dimensions on these so that I know how much draft I'm going to put on there. And this may be a good practice for you guys. So I'm going to go to, you can go to the snippet tool down here. I have this luxury of a print screen. And I'm going to take a picture. And I will print this out and get you guys a copy of this, okay? So when I do this, let me zoom this. So what we're going to do first is we're going to find out the distance of these features. So if I go to this extrusion and I say edit, dynamic edit, it actually tells me how far that is across. The first thing that I'm going to do, though, mine is in millimeters, and I think all yours are too. We said that this should be in inches. Everything that they told us about draft was in inches. Is that right? So if we let's just leave it in millimeters and let's start trying to understand what millimeters are to inches. So if I go to the first feature here and I say dynamic edit, I see that that's 70 millimeters across by 84 millimeters. The 84 millimeters is in the direction of pull, which is going to be our right datum plane. We could actually change the name of this to say split pull direction or whatever you want to. It's really good to name your datums. So 84 millimeters. So this, each way, if you put a dimension on your drawing, each way it's going to be 42 millimeters. So 42 millimeters each way. So it's going to be, we said in every 1 inch we needed 1 degree of draft. So if 1 inch is 25.4 millimeters, 42 millimeters is pretty near 2 degrees. It's pretty near 2 inches, right? That'd be 50 some odd millimeters, right? 54.8. So let's go ahead and put 2 degrees on these flat planes. Now we only need it on this side and the back side, right? I'm going to change this to annotation or something so that it doesn't highlight everything. This back side is going to be flat because it's going to have these pins on it and it's going to pull out that way. So we don't have to have draft on that. Anytime the metal touches a flat surface, it does not have to have draft on it. So this won't have any draft. These pins will. So let's see the depth of the pins. The depth of the pin, if I do dynamic edit or edit, it's going to show me 11 millimeters. That's about a ½ inch. So let's put a ½ degree of draft on there. Let's use a degree of draft for every inch. So let's go down to a ½ degree of draft. So this is going to be 11. And let's do 2 degrees each side. So a ½ degree on the holes. Now if we come over here, let's go to the next feature. And we hit edit. That's going to show me that it's 34 millimeters all the way across. It's 17 millimeters each side. So that's about 3/4 of an inch. So let's put 0.75 degrees on that. So each side will have 3/4 of a degree. And that was 17 millimeters each side. Okay. Now, when this piece right here is rounded, right at the top, it's going to be flat, but that's where your parting line is. So right here, it's going to be flat. That's where our parting line is. All the rest of this is rounded, so you're going to see that with draft, that's going to be absolutely fine. Any kind of rounds do essentially the same thing. So if I have that extrusion, let's look at this extrusion. If I hit edit, this is 17 and 16. Let's do 3/4 on each one of these. 17 on one side, 16 on the other side. And we're going to do the same thing on the inside holes. We're going to split draft those holes to each side. So the inside holes of the boss are going to be 3/4 degree as well. Okay, we're going to put the draft in before the rounds, and we said that the rounds are going to crash, but that's okay. It's going to work out fine. These flats, you see, if we look at this from the side, the flats that it's touching off on, these need to be drafted too, right? And if I say edit on this one, these things are 8 millimeters, so 4 millimeters each side. That's less than 1/4 inch. So let's go ahead and put 1/4 degree. 6.35 millimeters is 1/4 inch. I remember that by 25.4 divided by 2 is 12.7. Divided by 2 is 6.35. So from the splitting plane, each way, it's 4 millimeters. You don't want to go much further or much less than 1/4 degree. It's 1/4 of an inch is 6.35. It's 4 millimeters this way, 4 millimeters this way.
Are you measuring the width of that rib instead of the height of it? Don't we have to do both?
Because this is my, I'm sorry, I'm looking in the wrong direction, aren't I? This is the one that we're pulling against, right?
Yeah, of course it's also 8, so.
Yeah. Okay, so right here, these flats right here need to be drafted. If the right datum plane is our pull direction, the flats right here have to be drafted. So we're going to have 1/4 degree on each side of the flats. Okay. And how tall is this now?
Well, technically it's as wide as the base is.
It's as wide as the base is.
Isn't it? It tangents to the corner of the base.
Yeah. Let's look at that. So I've got that one. I've got that hole. We know what that is. The hole on the top cylinder is going to be the same as the outside diameters as well. The hole in this cylinder is going to be 3/4 degrees to each side as well, because it's split the same distance.
How many millimeters was that big?
It was 34, so 17 to each side. That's about 3/4 of an inch. Now if we go to this extrusion and I edit it, it's a radius of 32, but not all of it is that tall. So what might be good on this one is to use a tangent line on this and let this draft change and get steeper as it goes around. So we'll look at this one, but we can start with 1/4. Isn't that what we were saying on the other one? We said this is 10, so that's 5 each. That's 10. I'm sorry, it's almost a 1/2 inch. So let's go to a 1/2 degree on both sides. All right. So 1/2 degree on each side of the ribs.
Remember, it's only going to be 6 millimeters away from the next surface.
Right, right. So we're going to look and see what that does. Okay? So on a shorter surface, you're not going to have as much draft. This is going to have a lot more draft down here. It's just going to be angled further, so it's going to be thinner down here. Okay, what other features do we have? This face is fine. Let me see, this face has to be split, right? Is that right? Because it's parallel to, anything parallel to this has to be drafted. Is that right? Anything parallel to this does not have to be drafted. That's where the steel's touching off. So the outside face of this, anything perpendicular to this needs to be drafted. That's a better way to say it. Okay. And then let's just for grins, let's go ahead and draft this threaded hole before we thread it. And why would we even thread it? We wouldn't put the thread in the model. We'll have to tell them it's a secondary operation later. Now what we could do is go in there and make a tapered hole or a revolved cut and then put the threads in. Then you're really going to see how much engagement you have with that. But if you have plastic, usually you're not going to tap it. You're going to have a plastite screw. Isn't that right? So let's take this thread off. I'm going to take this hole and I'm going to change it down to the specified size for a plastic hole that's going to take a plastite screw.